Hello, and today's learning target is I can solve and graph simple absolute value inequalities. Let's review. Absolute value. Absolute value is the distance between the number and 0. It's always a positive number. So we'll fill in here distance, between the number and 0. Always a positive. And it's written as a bar symbol with the variable or a number inside of the absolute value. Consider the following inequality. The absolute value of x is greater than 5. We can split this inequality up into two different inequalities. X is greater than 5 and x is less than negative 5. Don't want the marker, need the pen. And x is less than negative 5. This makes sense because when we take the absolute value of x, it needs to be greater than 5. So we are looking for numbers that have an absolute value of greater than 5. Let's continue on. Let's split the following inequalities and visually represent the solutions with a graph. So here I have the absolute value of a is less than or equal to 3. So I'll break this up into two cases. The first case is, I'll put it in blue, because blue is the color of first place. A is less than or equal to 3, so as we see it. Then the second case is a is greater than or equal to negative 3. Now I'll graph this. So I will put on my number line 0, negative 3, and 3, so I can incorporate all my numbers here. And I want everything less than or equal to 3, so filled in circle, and greater than or equal to negative 3. So that's going to be an and statement, and I know that because there's an overlap, right? You can see that there's an overlap there of less than or equal to 3 and greater than or equal to negative 3. We'll just leave our answer as a graph, so we just want to visually represent the solutions with a graph. Let's look at the second example. The second example says the absolute value of t is greater than 2. So let's split this up into two cases. And the first case is t is greater than 2, and the second case is t is less than negative 2. So when I graph this, I'll put 0 in the middle, negative 2, and 2 on my graph, and I want everything greater than 2, open circle shading to the right, and less than negative 2, so an open circle shading to the left. So this would be my final, or my visual representation of a graph to absolute value of t is greater than 2. And if we were just to pinpoint what exactly type of compound inequality this absolute value is, this would be an or statement. And that's again because there's a gap. Okay, let's move on. Split the following inequalities and visually represent the solutions with a graph. Okay, so we have the absolute value of r is less than 1. So let's go ahead and write our two cases. R is less than 1, and r is greater than negative 1. I'll go ahead and graph my solution here, negative 1 and 1, 0 in the middle. And I will put an open circle at negative 1 and 1, and I want everything less than 1, but greater than negative 1. So I'll fill in the middle there. All right, the absolute value of n is greater than or equal to 4. So my first case is as I see it. Second case, I will flip the inequality symbol and change the sign. So n is less than or equal to negative 4. I can go ahead and graph, my solution set. Negative 4, 0, and 4. And then we'll put a closed circle at both of them. And less than or equal to negative 4 would shade to the left. Closed circle greater than or equal to 4 would shade to the right. And that would be my graph of the solution set to those absolute value inequalities. All right, now let's move on to a little bit more on our absolute value inequalities. So we want to still graph the following inequalities. The first case for this inequality would be x minus 4 is greater than 7. The second case would be x minus 4 is less than negative 7. So again, what's in the absolute value, we leave, but we flip the inequality sign and change the sign of the value on the other side of that inequality. So let's solve these inequalities. I'll add 4 and get x is greater than 11. And then over here, I will add 4 and get x is less than negative 3. I'll go ahead and I'll graph these. And we'll put negative 3, 0, and 11 to have that number line be as accurate as we can. We want everything greater than 11, so open circle at 11, and open circle at negative 3, and everything less than that. So that's what our final graph will look like of that inequality. All right, this next example, I will write the first inequality as I see it. So negative 2x minus 3 is greater than 5. Then the other one, negative 2x minus 3, is less than negative 5. So here we'll go ahead and solve, and I'll add 3 and get negative 2x is greater than 8. Divide by a negative 2, and when I divide with a negative, I have to flip the inequality symbol, so that becomes less than. Over here, I'll add 3. Negative 2x is less than negative 2. Divide by negative 2, and again, when I divide by a negative, I flip the inequality symbol. So I get x is less than negative 4, and then x is greater than 1. So I'll have an open circle at negative 4. Everything less than that will shade to the left. And then x is greater than 1, open circle, and we'll shade to the right. And that's the end of those two examples that were a little bit more than the first slide. A little bit more going on, I should say. The last thing we'll look at is consider the following inequality. The absolute value of x is less than negative 2. Are there any possible numbers for x here? No, the absolute value of a number can never be less than a negative number right here, right? So this is not possible because no, we can't have a negative value for the absolute value. So we cannot have the absolute value of any number being a negative number. So this is not possible, no solution. Thanks for listening. Have a great day. Bye-bye.